Good evening, my dear friends. Today I'm going to explain you the concept of orthogonality. It is very much important for GATE exam, especially GATE exam and some other PSU exams. So this is the very basic concept. It is much useful for communication, in communication, networks and signals and system in order to find the power and energy. Here the orthogonality concept is the main key concept I can say, because so many people need to find out the power when they give signals and all, right? So multiple signals will be there. So from that multiple signals, you need to find the energy and the power. So when you can find out in what condition to be met, everything to be known. In that case, orthogonality is a very much key player to find out energy and power. Here, orthogonality. This is the concept of orthogonality. Here, the definition it is: if two signals, which one, x1 of t and x2 of t, these two they have given, and they are saying they are to be orthogonal. Okay, these two signal x1 of t and x2 of t are said to be orthogonal if when the condition it should be satisfied, like finite to infinite x1 of t the x2 of t conjugation should be equal to 0. This is the definition. But suppose these two are real signals, then what should be the condition? Finite to infinite x1 of t x2 of t equal to 0. Yeah, like the area of these two signals being multiplied will be equal to 0. You didn't get right? Let me solve one question, easily you will get to know. But suppose they have given a signal, small signal, I can write problem I will solve. Just this is 4, you can say 0 to 4 to 4, here minus 6, and this is x1 of t with respect to time. One more signal x2 of t, they have given 0 to 4, this is minus 2 3. Then what could be the answer? Any guesses? The area of these two, total area. How can you measure this? Like up to 2, start from 0 to 4. You have to multiply these amplitudes, the time period with respect to these two, you have to multiply time period. Got it? So 4 with respect to this time period, 4 into 3, 12. So from 0 to 2 it's 12. Okay, from 2 to 4, what about 2 to 4? Here minus 6, here it is 3. Sorry, here minus 6, here it is minus 2. 2 6 are 12. Again it's 12. So it will be like this. DC. What if it is plus 2, like it goes up, it will be different. So up to here. This is how you need to solve this. You got it right? Amplitude will be multiplied, the time period with respect to the time period. Okay, let me solve. Let me directly give you some signals, then easily you can solve. Actually, let's get into the proper understanding way. Okay, I'm giving you. So where you use generally the use of orthogonality, like use of orthogonality, where you use this? This is generally why we use this orthogonality for energy and power calculations. It's very much needed because you need to find out the energy, power in the network circuits, in their signals, and here in communication, and also here in signals and system, because you are dealing with signals, right? Dealing with signals and systems. So you need to find out the power and energy of those signals because you need to know the behavior of that signal. So in order to do so, you go for orthogonality condition. So I'm not going to directly tell you anything. Let me give you some questions, accordingly I'll solve. Got it? Here there is a problem. For suppose they have given like this. Which one? For suppose z of t they have given is equal to 2 sine 3t plus 30 degrees, 4 sine 5t minus 45 degrees. They have given this question. This is a signal, this combination of these two functions. So there are, so here you need to find out the power. How can you find out the power? How can you find out? They have given this question. Here I am going to give you some tricks. Like you need to follow this. Like the area of, you need to write down this note. The area of T naught of sine m omega naught t plus pi 1, this is phase, sine n omega naught t plus pi 2 into dt to be orthogonal. When if they are orthogonal, then only you can find out the power. That's said to be orthogonal when one condition, m should not be equal to n. These with respect to that frequency, the value should not be equal to, the frequency should not be equal. And the thing is, if frequencies are equal, still you have a chance to do. So still there can be orthogonality condition to be satisfied. Like how? The phase, you need to focus on the phase. Phi 1 minus phi 2 should be n phi by 2, should be 90 degrees. N should be odd order, like 1, 3, 5 and so on. Odd integer, like. See, I am telling you. So this is the question. Let us go through these questions and all. I'll solve some questions similar to this. For sure they'll be useful to you, because if they're not useful, then why will I teach? Why would I teach? I'm teaching you here because they are very important topics. Otherwise I could have taught you some other things, right, which are very easy way, easy questions. I could have preferred them, I could have chosen them. But why am I choosing these questions? Because these are very much needed for BEL exam, GATE exam, BDL exam, HAL exam, PGCL exam, NPCL interviews. Many ways they can ask all these questions. Very much needed to understand many other concepts as well. These are very basic things you need to understand before entering into typical questions and all. So first condition to be met, this orthogonality condition, the frequencies should be unequal. Even though if frequencies are equal, then you have to go for phase. The difference of that phase should be equal to n pi by 2. N is a odd order, odd integer. Now here the question is, I am showing you here 3t, right? Here 3t, here it is 5t, here 3t, here 5t. How can you solve this question? Yeah, it's easy thing only. The frequencies are unequal. So how can you solve when frequencies are unequal? You can directly use the formula equal to p square by 2. When power will be, it's because it's a sinusoidal signal, power will be p square by 2. But suppose, okay, you don't know this thing. First let me give you one basic thing. Just when signal is square signal, no, should not give like that. Simply I'll think that also can be known, but I'm directly going for when signal is DC component. Like 1 2 3 something, or a, but suppose a, consider a naught, then directly a square is the power. And DC component is given, this is a naught, what could be the power? Then directly a square. But suppose if AC component is given, that is sinusoidal, like sine, cos, like that, etc. is given, then power is equal to a square by 2, like a sine theta something they'll give. The coefficient of that sine will be a square by 2. This you need to follow that. Okay, from that question I want to solve this question. So here it is 2, here it is 4. It's a sinusoidal, so it's AC signal. Okay, here 2 square by 2 plus power is equal to 2 square by 2 plus 4 square by 2, then 4 by 2 plus 16 by 2, 20 by 2 is equal to 10 is the power. Okay, this is easy because the frequencies are equal. Okay, what about if frequencies are if frequencies are unequal? Okay, let us look into that question where the frequencies are equal. But suppose there could be a question like frequencies are unequal, like problem is equal to, suppose consider z of t is equal to 2 sine plus 30 degrees minus 4 sine okay. Here is a question. Here frequencies are equal. Now these two are equal. Equal means it is violating that first condition, right? This condition is getting violated. Then what you can do? You can go for the second one. Here the frequencies are equal, then you have to check the phase. If still the phase is not satisfied, then means it is 0. But let us look into this question. So phase difference is 120 minus 30 is equal to 90. So 90 degrees. So it is satisfying. So what could be the power then? 2 square by 2 plus 4 square by 2. I mean minus 4 square by 2. 4 by 2 plus 16 by 2. Still 10 is the answer. You got it right? This is how you need to solve this question. Actually you should see the difference, like 30 minus 120, even though it is same only, because minus 90 will come, so minus 1 into 90 degrees, still it is same only. That's why higher minus lower I have taken. This is fine. Okay, let us look into a question where it is in cosine function. The question is in cosine function. 2 cos 3t plus 30 degrees plus 5 cos 70 minus 45 degrees. This is a question. Here sine function I have told you the conditions. Now here this is the condition I told you. This is the condition. For cos function, what could be the condition? These two are cos. Okay, different frequency they have given. Okay, here you can directly solve. But before that, I want you to note down one more note for cos function. Like when both are cos given, cos something and cos something, like similar to this one only, I'm not repeating that. M now phase 2, like what you have to do, M not equal to N, then directly you can use orthogonality condition, so it is satisfied, you can go for that question. If for suppose M equal to N, then what to do, you have to check the phase difference. These phase difference should be same like N pi by 2, same like before. So how you can solve? For sine cos both are same only, because why I was holding you people, because you need to know there is no much difference, but you have to focus on that question. People think that it is sinusoidal, it is cos function, it is sine function, it may be different like that people think, but don't, it's not having any difference. You need to focus on the question. What could be the power? 2 square by 2 plus 5 square by 2. The answer is 4 by 2 plus 25 by 2. Overall it could be 29 by 2, 14.5. This is all. If frequencies are equal, then you can check the phase in the next question. Like if 30 degrees is given here, for suppose 120 degrees is given, then you can check the same. So okay, I am not going to repeat this question because it is similar to sine function. For suppose if the question is given hybrid, like consists the function of sine and cos. For suppose like a question, z of t is equal to 2 sine 3t plus 45 degrees minus 4 cos 5t minus 30 degrees. Then how can you solve this question? Here you must have a note, one more important note, that is if these in the function of, like, these in the function of sine cos sine m omega naught t plus phi 1 cos m1 n omega naught t plus p2 to dt, you can use dt, is equal to, then what could be the answer? To be orthogonal, m should not be equal to n, then it will be satisfied. Otherwise if m equal to n, here the phase difference should be equal to n pi. N pi, n can be any integer, there it should be odd integer only. That is the basic difference, you can focus on. So now here the frequencies are different, so directly you can use the formula like p equal to p1 plus p2. This p1 now p2, and 2 square by 2 plus minus 4 whole square by 2, then 110 is the answer. Okay, this you solved. One more important question. With this question I'll close this. With one more or two more questions, because with the DC component also I want to solve one question. For suppose z of t is given 2 sine 3t plus 30 degrees plus 4 cos 3t plus 210 degrees. Okay, what could be the answer? Final power. So here these are the amplitudes. Here the frequencies are equal. The frequencies are equal, then what you have to do next? Check the phase. The phase difference is 30 minus 210 now, equal to minus 5, like minus 180 degrees, minus 1 into 5, so it is satisfying. So the phase difference should be any integer, it is like it is any integer, so the phase condition is satisfying. So what could be the power? 2 square by 2 plus 4 square by 2, 10 is the answer. That's it. This is how we need to solve. In the final question it is, for suppose the question consists DC component 4 plus 3 cos 2t minus 30 degrees. Now you need to solve the question. What could be the power? You have to remember that. Here one more point I'm giving. For suppose the DC component is given with respect to sine or cos, sine of something or cos of something. It is always 0. It is always orthogonal, satisfies orthogonality condition. Okay, DC is orthogonal to each and every sinusoidal signal, that you need to remember. Here then what could be the answer? I already told you when DC component is given, then directly you can a is given, for suppose a equal to a square only. So this is the power. Here 4 is a DC component, so 4 square. This is a sinusoidal signal, so 3 square by 2. What could be the answer? 9 by 2 means that 4.5 plus 16. So otherwise you can mention like 16 plus 9 by 2, 41 by 2. This is the answer. This is how you need to solve these questions. For suppose if they can give like a question, I am just telling you concept, you need to solve that. For suppose if they give you question, you need to solve and give the answer. Otherwise, if they give question z of t is equal to 2 sin 3t plus 4 cos 3t plus pi by 3, then how can you solve this question? Looks tricky, right? What is the, here they have given the question like this. What you have to do, this is one term, this is, they have given like this. So in that case what you have to do, you have to expand this. Take cos of a plus b, cos a cos b minus sin a sin b. You have to expand like this, and you can check the orthogonality condition and solve it like this. This is how you need to solve these questions. Actually today my pen is not working properly, that's why maybe the writing a bit different, but still it's understandable. You need to focus on these formulas, what and all I have given, and these conditions also to be satisfied. These are the orthogonality conditions, then only you can measure the power. Without solving this, you can't go to any other way. Okay, if you need anything you can ask me also. I can tell you the difference of RMS, normal power, peak power. Anything you need also you can ask me, you can comment over there. I'll explain the concept. Thank you.